Now that we've talked so far about how the brain works, and we've talked about how axons conduct an electrical impulse by an action potential, how does it get to the place that we want to do something? So, as you can see here, an action potential comes down a neuron, and then it connects with something else. Now, it could be another neuron like I've got in this picture here. Could be a gland, could be a muscle, could be an organ like the eyes, a sensory cell. In this case here, though, you have two different cells. So the action potential is coming down the first cell, and it's going to meet another cell, but it's not going to make a connection with it. It's going to come very, very close, but it's not actually physically connected to it. There's going to be a space in between, and that space, as you can see here, is called a synapse. Okay, and I'll show you a blow-up of it in a second. So here comes the action potential, the electrical impulse. It's going to come down here, and it's going to then release a chemical which is going to diffuse across this open space, and then it's going to make contact with another cell which will start a new action potential, and it'll continue on its way. So in other words, electrical, chemical, electrical. Or another way of thinking about it is that electrical is really fast, then it goes slow, and then it goes fast again. So there must be some reason that the cells want to slow it down here. And we'll see later on why that is. All I want you to know for now is that what happens before the synapse is called the presynaptic cell, and what happens afterwards is called the postsynaptic cell. Let's take a look at this a little closer. So here we can see that an action potential is coming down this way, right? It's going to then release a chemical, which we call a neurotransmitter, which is going to go ahead then and kind of diffuse slowly across this open area, this synapse, right? And then it's going to make contact with receptors over here on the postsynaptic cell, right? And that's going to cause a new electrical action potential to start here and go on its way. And this will keep going on happening until these neurotransmitters are broken down and they're taken back up into the presynaptic cell. Now, the question comes up, why is it that we want to slow it down? And the reason it's not hardwired one neuron to another is that it might be that you want lots of neurons to come in. So let's suppose that this is the postsynaptic area here. It isn't just one neuron coming down there. There could be a bunch of them, all these guys coming down. And they may be bringing information from many different places, right? And so what happens is that the chemicals then all come in here, and they go into the soma, remember the processing center of the postsynaptic neuron, and they may fish it out. So some of these may be telling you you're experiencing pain. Some of these may be telling you you're experiencing cold. Some of them may be telling you things are not so bad. And you got to kind of sort out all this information in the postsynaptic cell and then make a decision. If the wires were hardwired, you couldn't really do that, right? Okay, let's go ahead and draw this picture down there, and let's go ahead and outline how does the synapse work. Okay, so let's go ahead, and I'm just going to make up numbers here. Once again, you know, there's no steps here. I'm just sort of making them up. But let's go ahead and say number one. So number one, an action potential goes all the way down the neuron, and it comes to the end of it, which we call the synaptic cleft. So an action potential comes to cleft. Okay, so I'm just going to go ahead and, what color will we do it in here? Let's go ahead and do it in black. That's the easiest color, right? So here comes the action potential down the line. So that was step number one, yeah? When it gets down to the synaptic cleft, what happens then is it causes a gate to open up here. And that gate there is only made for calcium. So let's go ahead and add that in there, right? So number two then, we're going to go ahead and put in, let's see if we can get that in there. There we go, number two, right? Calcium gate opens and calcium enters. Okay? So this is another ion we haven't talked about yet. So let's go ahead and put in the calcium here, right? So I'm going to go ahead and put in calcium Ca, right? And that enters into the cell. So that's going to be step number 2. Now, what happens to the calcium when it gets in there? Well, it causes a chemical, which is being stored down here, and the chemical is called a neurotransmitter. And it causes this chemical to be released. So that's step number 3. And I'm going to indicate that as NT, a neurotransmitter. That's a special chemical, right? So let's go ahead and add this in here, over here, right? So step number 3, right? Neurotransmitter. I'll spell that out for you for now, right? Neurotransmitter, transmitter, released in Synapse. So this neurotransmitter then diffuses slowly across it, and then it makes contact on the other side there with a receptor. Now this is the postsynaptic neuron, right? So it makes contact with these receptors over here. And when it makes contact with those receptors, something happens. So let's go ahead and write that down here. So the neurotransmitter, and I'm getting a little lazy now, so I'm going to indicate it as NT, binds to receptor. Okay? And what happens when it binds to the receptor? In the postsynaptic cell, it starts a new action potential. So in the postsynaptic cell here, we then start a new action potential. So there it goes. So that's number action potential. So this was number 4 over here, and then it starts a new action potential. So here we go, right? Electrical, chemical in the synapse, right? And then electrical again here. Now these guys are going to keep doing it until an enzyme comes and breaks them down, and then they diffuse back up here. So that's going to be step number 6, right? So they're going to keep working until enzyme breaks them, okay? And then they diffuse and they come back there. And then there's a special pump, which we call a reuptake, which is going to bring them back inside the presynaptic cell. So reuptake, oops, that's not right. Reuptake pump brings them back in. So then they come back in. So that's going to be, what are we up to? Step number 7, yeah? So let's go here. That's going to be step number 7 over here. So then they go back into the cell and they return to their starting position. Now we're going to find out later on that what a lot of psychoactive drugs do is they interfere with this process, because as long as they sit here, if they don't get broken down, they'll keep acting, and that tells us a lot about how drugs work. So that's my quick little outline, and next time what I'm going to tell you is how are various ways that we can change this situation, right? And we'll also talk about what type of neurotransmitters we could have.